Hello friends, good morning all of you. Here I am Gadekar Sachin Pandit. Today we are discuss terpenoids and alkaloids. Okay, so last lecture we are discuss a classification of terpenoids. Okay, so in this classification and class of terpenoids is depends on number of presence of isoprene unit. Suppose presence of one isoprene unit is the hemiterpenoids, class of hemiterpenoids, an example of isoprene unit itself. Suppose compound containing two isoprene unit C5H8, then we consider monoterpenoid. Similarly, three isoprene unit present, then we considered sesquiterpenoids, then di, tri, tetra and poly. Okay, so this class of terpenoids depends on the presence of isoprene unit. Then also considered as a classification of terpenoids. Okay, monoterpenoids. Monoterpenoids classify in acyclic, monocyclic and bicyclic. Okay, then we are discussed isoprene rule. Okay, so next today we are discuss a general methods of structural elucidation of terpenoids. Okay, so structural elucidation methods, first is the analytical method. Okay, so in this we are discuss a molecular formula, unsaturation, nature of oxygen atoms, number of ring, oxidative dehydrogenation, dehydra- dehydration and dehydrogenation. Okay, so structural elucidation in analytical method we use molecular formula. Okay, so in this molecular formula we use a qualitative, quantitative and mass analysis. Okay, so there are different methods to use for structural elucidation of terpenoids. Molecular formula, unsaturation, nature of oxygen atom, number of rings, oxidative degradation product, then dehydration and dehydrogenation. Okay, so these analytical methods used for structural elucidation of terpenoid. First, molecular formula. Okay, so these methods used for structural elucidation. First, qualitative method, then quantitative method, and then mass spectroscopy. These three methods used for molecular formula structure determination. Next is the unsaturation. Okay, so these methods used to determine by the formation of addition product with reagent like hydrogen, halogen, hyd- halogen acids and nitrosyl chloride. Okay, so these determine for the addition product. 1 mole of H2 hydrogen for each carbon double bond carbon. Okay, so example, cadmium. We use a hydrogen molecules for reduction in presence of palladium to form a tetrahydrocadmium. Okay, so reduce these molecule means addition of hydrogen in alkene, in double bond unsaturated compound. Okay, so the molecular formula of citral is C10H16O. It contains two double bond and one oxygen atoms as a carbonyl group. The molecular formula of C10H22 correspond to CnH2n plus 2 means general formula of acyclic terpenoids. Okay, so citral is the acyclic compound. Okay, so this is the another method for analysis in unsaturation. Next, nature of oxygen atom present in terpenoids. Okay, for example, we use a hydroxy group. Suppose alcohol reacts with anhydride to form acetate and acid. So example, these benzene ring contain nitro group and acyl group. Okay, so this acyl group reacts with alcohol to forms a 3,5-dinitro benzoate. Means esterification reaction occurs. Nature of hydroxy groups is revealed by the rate of esterification. Primary alcohols undergo esterification more easily than secondary and tertiary alcohol. Okay, so these methods to determine the nature of oxygen atoms are present. Okay, first hydroxyl group in esterification reaction, and this esterification reaction depends on rate of reaction, presence of types of primary, secondary and tertiary alcohol. Okay, suppose present primary alcohols, its rate is higher than secondary than tertiary. Next method, carboxylic group. Okay, if terpenoid soluble in sodium bicarbonate and gives effervescence, it indicates the presence of acidic groups in terpenoid. Okay, so suppose terpenoid containing carboxylic acid, they reacts with sodium bicarbonate to form a salt of sodium salt. Okay, and evaporate carbon dioxides and water molecules. Okay, number of OH group is estimated by titration against the standard alkali solution such as sodium bicarbonate. Okay, so this is the another method. Okay, so next is the carbonyl group. If terpenoid present carbonyl groups and they react with sodium bisulfate, okay, to forms a sodium bisulfate derivative. Okay, another example, if carbonyl groups are present in terpenoids, they react with hydroxyamine to forms a oxime. Another method, if present carbonyl groups such as aldehydes or ketone, they oxidize to form a acid. Suppose terpenoid containing RCHO means aldehyde and they oxidize to give acid and they determine in titration. Okay, this is the another method. So next method, compound containing oxogroup, terpenoids from oxime with nitrous acid and benzylidene derivative with benzaldehyde. Okay, suppose compound containing oxogroups, they react with aldehyde in presence of sodium hydroxide to form benzylene derivative and they confirm the terpenoids contain oxogroup. Oxogroup CH2 C double bond O. Okay, so this is the oxogroup and these oxogroup reacts with aldehydic group to form benzylidene derivative. Suppose another example, oxogroup CH2 C double bond O reacts with nitrous acid O double bond NOH in presence of alcohol, in presence of acid, mineral acid to forms oxime and they confirm presence of oxogroup in terpenoids. Another example, presence of acetyl group. Acetyl group is the CH2COCH2. It is the haloform reaction. it confirms in haloform reaction. Suppose terpenoid containing CH2COCH3 group, acetyl group. This acetyl group reacts with bromine in NaOH, alkaline bromine, Br2OH, to form say acid. Two types of acid. Okay, a simple and other is substituted groups are presented. Okay, so they confirm presence of acetyl group. Another example, on strong oxidation with Cr2O3, chromium oxide, it gives acetic acid. Another example of oxidation, and it confirms presence of acetyl group in terpenoid. Next method is the degradation of product. Okay, degradation product, suppose terpenoids studying oxidative degradation products, we can find out the position of olefinic bond such as primary, secondary, tertiary alcohol present in terpenoids. Okay, so alkaline KMnO4 reacts with compound or osmium tetroxide. It reacts with compound. If compound contain double bond, it gives diol. Okay, so it is the another method for degradation of terpenoids. And alkaline we use KMnO4. If compound containing double bond, it gives a diol, and it confirms the presence of double bond in terpenoids. Tri-substituted olefin gives ketones and acid. Primary and secondary alcohols are oxidized to give a acid, while tertiary alcohol does not oxidize with KMnO4 and osmium tetroxide. It means that we confirm presence of type of hydroxy group, type of double bond unsaturated. Okay, so using this test. Another method, degradation of products, we use chromium tetraoxide, chromium oxide. It is a strongest oxidizing agent, so bring about oxidation of tertiary alcohol. Okay, so this is the degradation products methods to illustrate the structure of terpenoids. Another example, reaction with ozone. Okay, another example, reaction with ozone. Terpenoids reacts with ozone to yield carbonyl compound, and which is helps to know the position of double bonds in terpenoids. Okay, ozonolysis reaction. Terpenoids reacts with ozone to yields carbonyl compound, and it helps to know the position of double bond in terpenoid. Okay, so terminal alkenes are present. Okay, in terpenoids, terminal alkene gives formaldehydes as a one of the products, and suppose tetra substituted alkene gives diketone. Okay, terminal alkene present, it gives aldehyde, and tetra substituted alkene gives ketone. Okay, so this ozonolysis confirms the position of double bond, either terminal or substituted. If terminal double bonds, to produce a aldehyde, if tetra substituted, to produce a ketone. And second is the performic acid. Okay, suppose in this reaction alkenes from epoxide with performic acid, which on hydrolysis to give a diol. So another method is the dehydrogenation. Dehydrogenation remove of hydrogen in compound. Okay, so this is the another method. Dehydrogenation is a carried out by heating with sulfur, selenium, palladium, zinc, and the product obtained are examined, such as this cyclic compound reacts with selenium in presence of heat to form a naphthalene. Okay, another method, dehydration, means remove of water. Okay, so example, terpenoids are heated with dehydrating agent like potassium bisulfate, zinc chloride, P2O5, concentrated H2SO4. It used as a dehydrating agent, and we confirm a terpenoids dehydrating agent. Okay, so this is the methods of dehydrating agent we use, such as potassium bisulfate, zinc chloride, and P2O5, and concentrated mostly use paracumene. Okay, so this is the methods of dehydrating agent. Okay, structure elucidation method, we use a different method. Okay, so if any queries, then comment and ask me. So next lecture we are discuss a remaining part, citral. Okay, now today we are stop here. Thank you for watching this video. Have a nice day. Thank you for watching this video. Have a nice day.